Hi guys, and welcome to the video for properties of chords. So in this video, guys, we're going to be applying the properties of chords to circles to find missing measures. Those missing measures could be arcs or other chords, or even radiuses. We're learning this because chords are used in engineering and design when dealing with circles and supports. And you're going to be able to find the measure of arcs or angles using chords or chord measures properties. So let's get started. Definition of a chord. A chord is a line segment whose endpoints are on the circle, and a diameter is a chord that passes through the center of the circle and can be broken down into two smaller radii. So, the first property of chords relates to central angles. If two chords in a circle are congruent, then they are part of two central angles that are also congruent. So, if chord AB is congruent to chord CD, like shown, then central angle AXB is congruent to central angle CXD. And then by definition as well, that also tells us that arc AB is congruent to arc CD. Seeing as their central angles are congruent, then their intercepted arcs must also be congruent as well. So let's put this principle to use. Real quick, it says that you have a 70-degree angle here, and then you have a congruent chord, two congruent chords facing each other within the circle. So that simply means that W is equal to 70 degrees. Since this chord and this chord are congruent, that means that this angle and this central angle have to be congruent as well. So W is equal to 70 degrees. Okay, and then I have another question. What is the perimeter of OPBDQ? So that is asking me to find the perimeter of this shape, OPBDQ, and then go back to O. So I know two of the segments. It says that AB is 6, and it says that CD is 8. Um, so a later property that we're going to get into that will help us a little more with this is that when the arc or the chord here CD, it measures 8. When a radius like OQ intersects it at 90 degrees, it cuts it in half. So this would be 4 up here, and this would be 4 down here. And then the same thing can be said for AB. This would be 6, intersects at a 90-degree angle, so this part would be 3, and this part would be 3. So the perimeter of this shape would be 3 plus 4 plus 3 plus 4 plus 6. So it would be 3 plus 4 plus 3 plus 4 plus 6. So I have a total of 7, 14, 20 at 20 units as my perimeter. Okay, chords and arcs property. If two chords in a circle are congruent, then the measure of their intercepted arcs are also congruent. So this was briefly mentioned back on this page here. I kind of said it, hinted it with the central angles property. But if two chords are congruent, like here LM is congruent to XY, then it means that arc LM is congruent to arc XY as well. So let's take a look at that in action. So here's an example. So it's a two-parter. Circle A is shown. Find if the measure of arc BD is 125 degrees. Find the measure of arc CD. So they want me to find this. Well, I do know that BD and CD are congruent chord-wise. So I'm actually going to type this because I don't want to write a ton. Since chord BD equals chord CD, then arc BD equals arc CD. So the measure of arc CD is equal to, the measure of arc CD is equal to 125 degrees. Okay, so now I'm going to blank the problem, reset it. If the measure of arc BC is 80 degrees, so this part is 80 degrees up here, find the measure of chord, that should be the measure of arc CD. My line got flattened. So, what that means is I know, so I'm going to go back to text again. So since chord BD equals chord CD, then arc BD equals arc CD. So I don't know the measure of either BD or CD, so since they are the same, I'm going to mark them with a variable, x, and x degrees. I don't know how many degrees, but I do know that they must be the same letter because they are the same measure. So what I can do then is write an equation. I can do a nice simple equation of x plus 80 degrees equals 360 degrees in the circle in total. So, so here is BD, CD, and CB is here. So that's all three arcs that are given to me in the circle, and they must total to 360. So now I can solve this equation. So I get 2x plus 80 equals 360. So I'm going to subtract 80 from both sides to get 2x equals 280. And divide by 2 to get x equals 140 degrees. So arc BD and arc CD equal 140 degrees. Okay, so another example, what is the measure of all the arcs in the circles below? In the circle below, I'm not given anything. They give me a triangle and they say all three sides are congruent. Okay, so let's parse out what we know. So no measures, inscribed triangle, and triangle is equilateral. So all sides are congruent. And then I think I also noticed that BC, CD, and DB are all chords. Okay. So if BC, CD, and DB are all chords, so then I could actually say, since all the sides are congruent, I could say that BC is congruent to CD, which is congruent to DB. Okay, so then what I can do now is I can put a variable there. I'm going to put a variable x. I'm going to put a variable x here, and I'm going to put a variable x here. Because BC I'm going to represent with x. Since they're congruent, I can use x again. And since they're congruent, I can use x again. So since all of these are congruent, that allows me to put an x on every single arc measure since I know that they all have to be the same missing amount. So since they're the same missing amount, I can use the same variable to represent them. So then I will write myself an equation. I know that arc BC plus arc CD plus arc DB has to equal 360 degrees. So then substituting the letters in, it would be x for BC plus x for CD plus x for DB has to equal 360 degrees. So then we will split it up and get, or add it together and get 3x equals 360. And if you divide by 3, x equals 120 degrees. So what is the measure of all the arcs in the circle below? 120 degrees. All right, so let's talk about some other chord properties. We have the chords and radii property. A radius that passes through a chord at a 90-degree angle bisects the chord into two equal parts. So if the radius xd, so x to d here is a radius, passes through chord AB at a 90-degree angle, so it has the 90-degree angle here, then it means that AM is congruent to BM. So AM is the halfway point, and MB is a halfway as well. Those two segments are congruent. The two R's here represent congruent radii. So in essence, what this creates is two congruent right triangles. And because they'll share this side in common. So it creates two congruent right triangles, and then it also creates a isosceles triangle if you were to go to XAB. So there's some extra information here. So creates XA triangle XAB, which is isosceles with AX congruent to XB, and then it also creates two congruent right triangles, and those right triangles are XAM and XBM. So let's take a look at this property in action. So in circle A, BD equals 12 and AC equals 3. Find the measure of the radius AB. So I know, so let's start off with things that I know. I know that AC intersects BD at a 90-degree angle. And then I know that AB is a radius. And I know, by the look of it, triangle BCA is a right triangle. Okay, so the first thing I can apply is that AC intersects BD at a 90-degree angle. BD is stated to be 12. So if I go from here to here, that distance is 12. Since AC intersects it at a 90-degree angle, this and this half are congruent. So if I take 12 and split it in half, it would be 6 and 6. Okay, so I have two sides of a right triangle now. If I focus specifically on triangle BCA, so I've used that fact, I've used this fact, and now I'm going to use the fact that it's a right triangle. A right triangle with two sides, I'm looking for this missing side, so I can go ahead and use everybody's favorite, the Pythagorean theorem, in order to find x. So I'm going to set it up as 3 squared plus 6 squared, since they're both the legs, equals x squared. So I'm going to get 9 plus 30. Oop, my writing went a little off the wire there. 36 equals x squared. So I get 45 equals x squared. Now I know that 45 is not a nice number when I go ahead and take the square root of it. You can round it to the nearest tenth. So we're going to round to the nearest tenth. So I'm going to type that. So round to nearest tenth. So when I take the square root of both sides, I get x on the right-hand side. X equals 6.708. So rounding to the nearest tenth, we're just going to get that this is approximately equal to 6.7 units. So what is, find the measure of radius AB? This circle has an approximate radius of 6.7 units. Taking a look at another example of the radius chord diameter or radius chord 90-degree angle property. In the circle, AB is 20. What is the measure of X? Okay, so let's take a look at things that we know and we are given here. So AB equals 20 and is a chord. I know that X is the measure from the center to AB. And it's not explicitly stated, but I can infer from the picture that 12 is the radius. Radius of the circle. So, these are things that I know. So then, if this is 12, that means this is 12 down here. So then I can go ahead and add to my, I'm going to add to my knowing, stuff that I know. Segment X hits AB at a 90-degree angle. So then that means I can use the special property, and the special property says that these two intersect at 90 degrees and can, therefore, I can split this into two congruent halves. So this is 10 up here, and this is 10 right here. And now I think I have all of the information that I need to solve this problem. So I'm looking for X. So X is a leg, and 12 is the hypotenuse. So X is a leg. 12 is the hypotenuse. So I can set up a Pythagorean theorem here. X squared plus 10 squared equals 12 squared. So then if I square it all out, I get x squared plus 100 equals 144. So then I end up with x squared equals 44 when I take away 100 from both sides. I'm going to square root both sides now. X is equal to, so the square root of 44 is not a nice number. It's 6.63. So it's approximately 6.6 units. So X is about 6.6 units. Okay, and finally, or not finally, I'm not so sure, but the next property is the perpendicular bisector of a chord property. The perpendicular bisector of a chord, like such as a radius or a diameter, always passes through the center of the circle. If AM is congruent to CM and BXD intersects it at a 90-degree angle, then BXD must go through the center of the circle, guaranteed. It's either a radius or it's a diameter, guaranteed. So let's go ahead and continue. Let's apply this property. So find the measure of X, and we're also going to find Y. So if this is true, okay, this is a 90-degree angle. So I know that this and this have to be congruent. And therefore, this splitting down the middle is a radius, a diameter as well. And so 3x minus 4 degrees refers to this arc up here. and 5x minus 18 refers to this arc up here. So if I'm going to find the measure of y, I know immediately through the last property that these two segments have to be congruent. So I do know in my equation, or I do know the first equation I can write. Know that the two y expressions must be equal because of radius property. So I can say that y plus 4 equals 2y plus 1. So I can go ahead and start subtracting stuff from both sides. I'm going to take a y away from both sides. And I get 4 equals y plus 1. Take away 1 from both sides, y equals 3. So if I substitute them in, I would get 7 here, and I'd get 7 here. The next thing that I'm going to want to do is if these are congruent, these two segments here, remember this makes 90-degree angles here, here, here as well. It means that from this point on the circle, so I'm actually going to need to switch colors. So go to pen. From this point here to this point here to this point. So this and this segment would have to be congruent. So that means that I can write another equation. And so I know that the arc expressions must be equal. So now that means I can write an equation, and that equation would be that 3x minus 4 has to equal 5x minus 18. So if I go ahead and start moving stuff around, I'm going to take away 2x from both, or 3x from both sides. And I get negative 4 equals 2x minus 18. So I'll add 18 to both sides. And I get 14 equals 2x. So x equals 7. So if I plug 7 in, 35 minus 18 is 17 degrees. And 3 times 7 is 21, minus 4 is 17 degrees as well. So that would be how you apply perpendicular bisector and radius bisector properties. Another example here, in circle A, CE is a diameter. So from C to E is a diameter. And the measure of arc BE is equal to 110 degrees. Find the measure of the other arcs. So they're asking me to find the measure of BC. They're asking me to find the measure of CD. And they're asking me to find the measure of ED. So the first thing that I know is that this and this are congruent. Because they're bisected at a 90-degree angle, which means that this up here and this up here are congruent. So I'm going to write down things that I know. Know that we need to put a letter in the middle, actually, to help out. So I'm going to put M here to mark the point in the middle. I know that BM is congruent to MD, and arc BC is congruent, is equal to arc CD. And then I also know, because CE is a diameter, I also know that arc EB plus arc BC equals 180 degrees. And then it's the same way around the other way. I also know that arc ED plus arc BC equals 180 degrees as well. So let's get this all figured out. If BE is 110, so I can use this equation of 110 plus BC equals 180. That means that BC is equal to 70 degrees. 70 degrees up here. And then, since that's the case, I know that BC equals CD. So 70 equals CD. So this is 70 degrees over here as well. And then it's the same idea. Arc ED. So it would be ED plus 70 degrees, since I know that DC is 70, equals 180. So ED is equal to 110 degrees as well. All right. The last property is called the chord distance property, and it says that two congruent chords in a circle are the same direct distance from the center of the circle. So, if the chords are congruent, AX is congruent to XB. Or the reverse is true. If XA equals XB, then you can say that CD is congruent to FE here. So let's take a look at that. Find the value of X. So I have two congruent segments here. So I know that the chords, I typed the twice, chords are the same distance from the center. The segments are the same length. So that means the chords must be equal. So since the chords must be equal, I can write an equation, and that equation would be 6x minus 7 equals 35. And then I can solve by adding 7 to both sides. So I would get 6x equals 42. So x equals 7. And it's just really that simple. When you have two chords that are the same distance apart, you can easily solve to find one of the missing ones by setting them equal to each other. So guys, we covered a lot in this one. This is a really long video. Remember that chords are line segments with their endpoints on the circumference of the circle. Congruent chords means congruent arcs. You can use chords to find the radius of the circle and vice versa. And then chords that intersect at 90-degree angles are bisected by each other. And then chords that are the same distance apart are congruent. That wraps up everything that we learned today. Thanks for watching, guys, and see you in the next video.